All right, welcome everyone. Welcome to this talk on Spring Boot 2. So before I start, I would like to ask you a few questions. Who's using Spring Boot already? Okie dokie. All right. Who's using Spring Boot 1.5, the latest production release? Okay, interesting. So that's 80% for Spring Boot in the room and 50%. Anyone using Spring Boot 2 yet? Yeah, someone very, not in production, good. Okay, right. So this talk is really about what you can expect from Spring Boot 2. We'll have a few demo running on snapshots, so on the bleeding edge. So I want to show you the new feature that, the main new features that you can expect from Spring Boot 2. One of them, of course, is Spring Framework 5. So a new major release of Spring Framework 5, it has been said also, it's one of the biggest release ever since 1.0. In Spring Framework 5, there is a story with Java 8 and Java 9, so we've raised the system requirements to Java 8. You can also, of course, run it with Java 9 if you choose to do so. But the biggest new feature is the support of reactive programming with Spring Web Flux. Most of the demos today will be with Spring Web Flux as a new way to develop web applications. But what I want you to keep in mind is that the traditional models of Spring MVC based on the servlet stack, so most of you are using Spring Boot already, so you know about that stuff. This isn't going anywhere, right? So it's a new option for you. So what I want to show you today is that with Spring Boot 2, you have even more options. So if you decide that you need to implement your next web app with Spring Web Flux, Spring Boot 2 will help you along the way, the same way that Spring Boot 1 does today with Spring MVC. So why would you want to use reactive programming anyway? Well, applications these days, they have several new characteristics. One of them is that you need persistent connection. So when you have a very fast connection, so the browser on the top, you need to provide feedback to the user as soon as possible. They don't need to refresh, they just need to see new events happening in the application live. So for that, there are several options in a servlet-based stack. Using SSE, using WebSocket are the two main options, and that requires a lot of resources on the server. But also today, most applications are mobile-friendly, and so you have plenty of mobiles connecting to your app. And those mobiles are sometimes on crappy networks, right? So that doesn't work. And what's the first thing that you do when it doesn't work? You hit the refresh button, which triggers a new connection to the server, and it also uses a thread. At the same time, your applications are more and more based on remote services. So you have to compose to call remote services, potentially with latency. You can see that this service down there is a bit slow. And when you combine all that, that's what's happening to your app. So Spring Web Flux and reactive programming is a way to better scale when you have a lot of concurrent users. And it's a way of better using the resources of your server. So it's not about pure speed. So it's not about going faster than a traditional model. It's really about how your system behaves when you have a lot of concurrent users. Reactive programming, so it uses reactive streams, and there is one implementation that we use in Spring Framework 5 called Project Reactor. And Project Reactor will give you operators that you can apply on data. So if you decide to keep the traditional model, you still may want to contact those remote services and compose them and deal with latency and concurrency. And as you will see, Project Reactor offers very powerful operators that you can apply on the data. So it will help you to compose data, apply filters on them, merge data together, as we will see. And that's very, very powerful outside of the main reactive use case. So what about Spring Boot 2? Spring Boot 2 is really about helping you on the infrastructure level with all that stuff. As most of you are already using Spring Boot 1, you know the kind of help you get from Spring Boot with an MVC app. And the message today is that we intend with Spring Boot 2 to deliver the same level of support for reactive-based web applications. At the same time, Spring Boot 2 is also a new major release, and it's a chance for us to revisit some of the decisions that we've made in 1.x and to improve some of those. We'll have a couple of examples about that. All right, so today we are going to work on a sample applications based on smart sensors. So smart sensors in my first diagram is those mobile phones on crappy network hitting your server, right? That's the thing you want to be able to scale. So on the right-hand side, we have zones, and each of those zones, they have smart sensors reporting a power usage. So every 10 seconds, they basically send their current power consumption. We have an app that we call the aggregator, that we will see in the example here, which collects that data. So it gets plenty of requests coming in. And its goal, it's basically to push that information, so to provide a centralized view of the data. And on the left-hand side, we have an operator, that's you. You want to know what's going on with the current infrastructure, what's going on with those areas. And we basically build a dashboard to have a consolidated view. All right, so let's see how it feels like. First of all, I have I'm going to increase the font a bit. So as you can see, plenty of data coming in from all those sensors, all those zones. You can see that it pauses at some point because, as I said, they report every 10 seconds their data. So once they've done that, there is nothing else to report. The next window, the next 10-second window starts, and they start pushing data again. So the aggregator in this example is a generator. So it's creating a random power consumption. That's not very interesting. What's interesting is how we are going to consume that data and actually display that in a separate application. So let's start this application for a start. So again, 2.0 snapshot, just in case the demo doesn't work, right? So, right. So the first thing that you want to do is you want to consume the data, right? So the stream of data I was just showing, how can you get that in a non-blocking, asynchronous, and neutral to latency way? So in Spring Boot 2, you can use Spring Framework 5's new web client API. You can, as always, if you use REST template, you can inject REST template builder to create your REST template. Same thing with the web client. You can inject a web client builder, which will have all the converters that are available in your Spring Boot application. And then you get measure firehose, which is the URI I was using. And then you map that to an object. So you map that to a flex. So you map that to a stream of data. The last operator, and it's one line, but it's very central, is share. So what that means is that that flux of data will be shared by all subscribers on the data. So if you have 10, 20, 30 components interested by that data to transform it, they will not issue 30 requests to the backend. You'll have only one request to the backend. And one new subscriber will join. They will basically go to, they will basically use the same content of data. So it's a hot source on which you connect to. And once the last client disconnect, cancel the subscription, then the remote call will end automatically. So it's actually very powerful. So I'm exposing that flux of data. And I can use it in a sampler. And this is to show you the kind of powerful operator that you can apply on the data. So I'm getting the data. then I'm creating a window every 10 seconds. So every 10 seconds, I'll get all the devices and all the zones, so all the devices for all the zones. Then I will group that window per zone. And then for that, so I will have one period of time and one zone. I will basically reduce the information to compute one item in my collection, which is the current consumption and the number of devices. So if I look here, I'm basically adding something to one instance. So basically, I have one item in my collection for one zone and one period that contains the power consumptions. Remember that all this is just defining your pipeline. It doesn't do anything. It's just you declare what should happen, OK? And once I have this, all I'm doing is saving that to MongoDB in this case. OK? So I have the app running, hopefully. Right. So first thing is I get an error page because mapping on the main page does not exist. So you may wonder, how do I do template rendering with a reactive app? Well, really, it's no different from what you used to with Spring MVC. So I have my time leaf template here, and that time leaf template is going to list the available zones, and it will provide a link to the data. So let's go to my controller. So I want to create a new mapping. So this is what I do. I basically create a rendering object for a view. The view is index. This is the name of the view here. And as we have seen, this view requires an attribute called zones. So that's this element. And that element is basically the zones that you want to give access to. Turns out I have a repository of all the zones. And as you can see, that repository is reactive as well. If you build a reactive-based web app or reactive app, essentially, everything needs to be non-blocking. So you need to use that mechanism from the beginning to the end of the request. So you notice that usually what you do is you put the collection of items in the model, right? And then you have your template iterating over the collection and render the data accordingly. In this case, I'm simply passing the flux. So I'm simply passing the publisher of the data, and the framework will make sure to subscribe to it. And once the data is available, render the template. We will see later there are much more powerful options. Right, so this is my graph. That shows the power consumption. I can make a typo here. So I could say 2, a zone that doesn't exist. And you can see that it says missing power for data zone. That's what you get here. So that's the switch if empty operator. So if I don't have data for that zone, then I'm able to trigger something else. And this is actually throwing an exception. And that exception is making sure that you get the not found HTTP status. Of course, I want to handle that and be able to provide a better error page. So I can create an error directory, and in that directory, I can create a view that matches the HTTP status code that I want to intercept. And then I get my error page instead. OK? So maybe you've been using that with Spring Boot 1.x already. Just to show you that those features are consistently applied if you decide to use a different option for your next app. So we've seen a very basic example of template integration. If you want to build a template, you need to put data in the model. In the case of a reactive app, all you can do is basically describing your pipeline up to the model, actually. So the way it works is you actually put the publisher of the data and not the data itself, because you can't block on that. One needs to handle that for you. So if you put publisher in the model, we will figure it out. We will basically not actively waiting, but once the data is available, we will render the template. So that's an easy option for template engines like FreeMaker or Mustache. But TimeLeaf and TimeLeaf 3 goes way beyond that with the bet of actually integrating reactive programming within TimeLeaf itself. So providing advanced support for reactive-based use case. And there's really two of them. One is called chunk mode, where rather than rendering the old template and writing the result to the output stream, is to give you the ability to fine-tune when TimeLeaf flushes data to the output stream. So it's a better usage of resources, because rather than rendering everything and then writing, you basically render and write chunks of your templates. So that's chunk mode. And there is another mode that's called data-driven mode, where basically TimeLeaf itself consumes the publishers. So you can put one special, as I'll show you in the example in a minute, you can put one publisher in the model with a certain flag, and TimeLeaf will actually subscribe to it. So TimeLeaf will render a piece of template and basically send that bit of template to the client. So if you want to render things that happen along the way, that's one great option to do it. As Spring Framework 5 and Spring Boot 2, Spring Data K is actually the first major release since its inception. So Spring Data was born in 2009. And this is the first major release since then. So you can expect, if you don't know, if you haven't been to Christopher's talk this morning, for those who haven't seen that, you can expect plenty of new features in Spring Data, better a review of the API, support of nullable, so now you can annotate your parameter of your repositories with nullable, support for optional, and of course, support for reactive programming as well. As I told you, if you build a reactive app, you need to be reactive end-to-end. That includes, of course, the data store. And there you can expect support for Redis, MongoDB, Couchbase, and Cassandra. So if you use any of those stores today, there is a reactive driver for it, and there is explicit support in Spring Data. Another thing that you can expect, and I will showcase, is infinite stream support. So basically, infinite stream support is you are running a query, and so you basically get back a publisher of that data. You can actually have a long-lived connection subscribing on that criteria. And when there are new items matching the criteria, when they are added to the store, you basically get them in push mode. Okay? So that's quite interesting. Yeah, so let's try to demo that. First problem. My graph does not update itself, right? So as you can see, I have 1 point every 10 seconds, as I told you. The backend is sending data every 10 seconds. You can see that here. So if I refresh now, I can see I have new data coming in. So it would be nice if I told you persistent connection, that's the laptop case. You would like in that case that the graph updates itself as data comes in. And remember, the data is coming from a remote service. OK, so first thing I need to do in order that to happen, so remember those data are saved in a collection here that we call Power Grid sample. I'm going to create a new query for my repository. So it's a Power Grid sample. I want that to be filter on zone, and I want to start after a certain timestamp. Okay. And I want to tell Spring Data, this is not a usual query. I want that to be a tailable cursor. So I want it to keep the publisher open and push me data as it comes in. I have that. OK. So next is to expose that in my web application. And the way to do this, to be efficient, is to use SSE, server-sent events. Little L. All right. So I want the updates for a certain zone. So in this case, this zone. So it's a get mapping on zones and the zone ID. That's the same thing as here, right? And I will give it an extra updates argument. And I want to say that I'm actually producing that the content negotiation kicks in. I'm producing server-sent event. And the return is actually the body of the response, and not a view. OK, so what do I do here? Well, I need to pass in an instance. So the idea is there are plenty of data in my collection. I don't care about data in the past. I just want data now, and that the connection keeps pushing me data as they come. So I'm going to say local date time now, and I will reset to the beginning of the minute. And all dates are in UTC format, so I'm using that. OK. So that returns a publisher, and I can basically send that publisher as a return type of my controller, and Spring Web Flux will do the rest for me. It's the same thing if you use Spring MVC today. It's no different. You can see it's same annotation, same method signature. Actually, it won't work because that needs to be a path variable. Right. It's the same thing, basically. OK? So it doesn't change much to what you used to. All right. So what is it again? Fin1 updates. There we go. So I have one element, and as you'll see, every 10 seconds, I'll have a new element that basically materializes the data that comes in. Okay? Very easy to do. So once you have that, it's actually not complicated to reuse that information in the browser itself to draw the graph. So my JavaScript knowledge is such that I actually have something ready for it. There you go. So you can see I'm creating an event source to the same URI. Every time I have a message, I already have a function here prepared that will update the graph for me. Did I save? I don't know if I saved. Yes, I did. OK. So now you can see the graph being updated automatically for you. And if we look at the network, to refresh that, you can see in the network the data comes in. And the graphs update itself, right? So remember, it doesn't matter how much clients you have actually hitting that server. Okay? So I've been lazy, I've been very lazy for the sake of the demo. But what I should have done is this one also needs to be shared so that if you have an additional client, they just connect to the existing tailable cursor rather than creating a new one. So if you do this, same as the client, you share it and you keep it as a field of the controller, it doesn't matter how many clients you have hitting the server, because they will all go through the same pipeline. So one connection to MongoDB, and basically multicast for all the clients. Right, so next up, we can see that there is a zone event there. What that's supposed to represent is failure scenario in the area. So if we have a sensor that reports a power consumption of 0, so we assume there is some kind of battery or something. So if there is a power cut for a certain device, we want to get a line there saying that device reported 0 consumption with that ID and that time. And we could use the same thing, right? So we could reuse a Flux like I've done and use SSC and then subscribe with SSC. But what I want to show you now is the data-driven mode of TimeLeaf, where I'm going to ask TimeLeaf to render a piece of HTML every time such event occurs, and then show you how you can actually add that to your page so that it's being appended to that zone. OK. So the first thing I want to do is I want to use TimeLeaf in such a mode. And for that, I need my collection back. I can't use the window anymore, right? Because I want the individual devices. So I don't want that item in the collection that gives me the full power and the number of devices. I want the original collection, the original Flux from the remote service. So remember, I told you it's shared, so that's perfectly fine. I'm just going to inject an extra service here. That's my measure collector. And I'm going to say, so remember, we are rendering bits of HTML. So let's see. Measure collector. So getting the data, the same data, so I'm connecting to the same pipe. And I can apply a filter operator to my data. So I want to say everything where power equals 0, I want that in. And if it's not the case, just discard that data. I don't care. So I have a faulty measures. Okay. Next is I want to use, remember I told you if you flag something in the model as TimeLeaf has to subscribe to it. So you need to wrap that to a class in TimeLeaf called reactive data driver context variable. It's very long, I know. Go complain to TimeLeaf if you want to fix that. And that actually requires two things, is the source of data, and when, at which occurrence we need to flush. So you may decide to buffer and only flush when you have certain events. In this case, I'm saying to TimeLeaf, every single time a device report a power of 0, flush. So I will get the update immediately. The default value is 10. And once I have that, I can say the name of the view, which is zone, and I'm searching for a selector called event. I'm going to show you that in a minute. And I'm adding a model called event stream with the stream, and I build. So back to the code. There is a diff with ID events, so that's the bit in the TimeLeaf template that we are going to render. And for that, it needs an event stream. Okay. So if I save that, let me check that. Okay, probably I need to tell some mapping here. So let's say events. Right. Is that still up or not? Yes. Okay. That's actually not up. Yep. Unless I made a typo. No, I didn't. Okay, let's see. Let's simulate a power failure and see if that works better. No, it does not. Okay. So I'm going to give up and check out this thing. What did I miss? Looks like the same to me. I missed something, but I don't know what it is. Okay, sorry. Right, so I've been a bit quick on that one. So on my remote service, so my remote service I told you is a generator. So I have this special endpoint where I can say, for that zone, say that the low and high value for power is 0. So basically what that's going to do is report 0 for every device in that zone. And as you can see, every 10 seconds, you basically have all devices for that zone reporting a bit of HTML. So if you want to integrate that in your page, so this is what you need to do. So basically, you have a new SSE sources. That's the endpoint I'm currently looking at. Then I'm searching for the events ID, so the div which has the events class ID. And then I'm simply adding the data. So I'm basically appending that bit of HTML to the data itself. So it's a very effective way to push this data while the rendering is happening on the server. So the rendering is happening on the server, you push the data being rendered, so you have all the power of the server. Then the client just adds that. So if I'm going back to Fin 2 to say something, or Fin 1, right, then I have my data here. And if I click, I can see that now the power is down for that zone. There you go. All right. So these are the few things that you can do with Webflux, and now Webflux changes the game for those use cases. Again, if you use Spring MVC today, it's perfectly fine, so it's not going anywhere. We're not saying that building a web application based on the servlet stack, that's dead. Don't do that. We're not saying that. We're saying there are use cases for that type of app, and there are use cases where using WebMVC or the Servlet API is perfectly fine. So if you're happy with your application, there's no reason for changing its architecture. And Spring Boot 2 will basically help you, whatever you choose. So if you choose to go with Spring MVC, you'll get help. If you choose Spring Webflux, you'll get help. And as you will see, if you choose even different architecture, we'll have a support for that. So one thing is Spring Boot Actuator. So those of you who are using Spring Boot, most of you know that it's an effective way to get management and DevOps feature added to your app. And if you use JaxRS or Jersey, you may have realized that Actuator doesn't really work well that way. You have to also add Spring MVC to make that work. So one of the challenges of adding more options to the portfolio and trying to make them consistent is also to reduce the burden and reduce the maintenance of actually offering all those options. So we've come up to a new way to create endpoints. So that's the Earth endpoint, the info endpoint. I'm going to show that in a minute. Those endpoints used to be, to some extent, coded as a Spring MVC controller. So it's very hard, well, impossible, to run those in Jersey without Spring MVC. But we had also to offer support for Webflux in 2.0. So we've changed the API, such as now there is a new model that you can use. And once you describe your endpoint with that model, basically you get deployment for free. So you can deploy on Spring MVC, you can deploy on Spring Webflux, and if you use Jersey, you can deploy on Jersey, natively on Jersey. If you use a different JavaDay implementation, it's actually quite easy to add support for that. So if you look at the code base in Spring Boot, there is one class to add support for Jersey. That's the class who register a Jersey resources programmatically. So if there is the same thing in other JavaDay implementation, that will work just fine. As I've told you, Spring Boot 2 is a way for us to revisit some of the decisions that we've made. And one of them is the Earth endpoint. So the Earth endpoint used to be a bit complicated to understand. So there used to be two use cases in the same endpoint, really. One is to give a public information about whether or not the application is up. So if you connect to it anonymously, you just want to expose the fact that it's up or not. And if you are connected, so if you have the credentials, you want to be able to see the details. So which component is down. You don't want to expose that to the public, right? And so there was this complex mechanism to choose between the two. In Spring Boot 2, there are actually two endpoints. There is status, which only expose the status, and Earth, which only expose the full details. So you don't have to, configure those independently now. Another major change in Spring Boot 2, and it's, again, this is across the board, this is not specific to reactive at all, is a completely new security auto-configuration. So if you've used security in Spring Boot 1, you know it can be a bit hard to understand because there is the auto-configuration for your app, the auto-configuration for the actuator, and eventually, that happens for most apps, your configuration, so the security items of your endpoints. And what that means in Spring Boot 1 is that you have security-related information potentially in 3 places, which is quite bad. So what we've done now, we've simplified that, and we have one auto-configuration for everything, and we will back off as soon as you provide your configuration. And not to basically ask you to redo everything, we provide security-based helpers to make that a bit more easy to read and easy to write. So in this case, what I'm saying is, I want that status and info to be available for everybody. I want that all other endpoints require a certain role, so you can put whatever role you want there. I want to make sure that static assets are available to the browser, basically. And all the rest needs to have a certain role. And of course, you can make that as complex as you want. But the point is, in one single class, you have the security for the app, the static assets, so the common stuff that your app requires. You have the security of the actuator, and you have the security of your own endpoint. So you have one class where everything is defined. Spring Boot 2 also moves all its metrics related information to a new project called Micrometre. Who knows about Micrometre? Okay, that's 2%. So think about Micrometre as the same thing as SLF4J, but for metrics. So we all know SLF4J is a way to code against a minimal API, and then you basically add a logging implementation on the class path, and it will use that. That makes sure that your code is portable, and if you decide to switch from log4j to logback, for instance, you don't have to change all your code. So Micrometre is exactly that, but for metrics. So Micrometre provides a minimal API and binder for a ton of monitoring systems. So you have the list there, and actually there are a bunch missing because there's not enough space on the slide there. And one thing which is also very important compared to what you get in Spring Boot 1, we switch from hierarchical-based metric to multi-dimensional metrics. So rather than having a very long name where you give the assets or you give the characteristics of the metrics, you have a relatively short name with tags, and you can add as many tags as you want. So one metric with plenty of tags, so you can search independently, versus one metric name which represents the thing you're actually looking for. So it's much more powerful. Right, so let's demo that. So I'm going to add, because I don't have the actuator yet in this app. Oh, that's very, sorry. So Spring Boot, starter, actuator, that's it. Yeah, IntelliJ do that. There you go. So I have application status. It's telling me the app is up. Not very interesting. Info, okay, no info. So let's have a look to the environment. So the environment endpoint is the endpoint that allows you to know about the configuration of your app, know which config keys have been configured, or know more about the state of the application. And that's 4.4. And that's 4.4 simply because I don't have Spring security on the class path. I don't want that information to be exposed by default, so I'm basically needs to opt in for those. And the way to do that, there's a property, obviously. It's to enable the web endpoint by default. Okay. Done. So if I do that, then if you know about the output format for Spring Boot 1, you'll see it's a bit different now. But one thing that's quite interesting is actually now we track where configuration keys are defined. So that's the origin field there. So we know when we start the app, not only the configuration key, the value, of course, in which file it is, but the exact precise location of the key. So if we look at, for instance, let's take this one that I just added. Okay. I can also go to a dedicated endpoint, which tells me this is where it's defined, this is the value. These are the candidates. No, so these are the places where it could have been, but it's only in one, and it's at 96 character 31. So if I go here, maybe you won't be able to read it, but that's line 6, character 31. So we are in the process of making use of that feature in IDE, so that once you get an error message or anything, you basically have a link, and that link points directly to that line. Now that I have the endpoints enabled, I can also fire this. It's a bit different now. There's a detail, so it's a bit more structured than it used to be in 1.x. And you can see that there is a disk status earth indicator there. And remember, we are in a reactive application. One might argue that, maybe it's not 100% true, but one might argue that disk status is actually a blocking operation. And you may have plenty of earth indicators that are actually blocking. So what do we do in this case is that we identify that the earth indicator is potentially blocking, and we run that on a separate scheduler. So we do that transparently for you. So if you have a reactive application with certain pieces, like the backend, or you're running batch in the background or whatever, and you want to make sure you can reuse the assets that you have, we will automatically detect that and move the execution to a separate scheduler so that it doesn't pose any threats. You can also, if you want to be a good citizen, and you surely want if you build a reactive-based web app, if you want to build an earth indicator that's non-blocking, and actually you'll have to, because the only thing you'll get is a publisher, so you really have no choice. We have a dedicated support for that, so let me show you quickly. So rather than returning health, which gives the Earth indicator for a certain endpoint, you can return a mono of else, and basically you can implement an interface called reactive Earth indicator. And here is my new aggregator, right? So if I shut down the aggregator now, it should go down. Okay. Right. So that was an overview of the things that you can expect in Spring Boot 2. Spring Boot 2 milestone 6 is for Monday. Actually, it was supposed to be today, which is the reason why I'm running with snapshots. We have release candidate 1 somewhere by the end of November, and we are still hoping to meet the 2.0 deadline by the end of the year or early January. So if you have questions, I have 4 minutes. And if you're shy, you can reach out to me, or you can come talk to me after the talk. Any question? Yes.
Thank you for a talk.
Where are you?
I'm here.
Oh, go. Sorry.
I have a question. Is it possible to move gradually to WebFlux API and using it simultaneously with Servlet API?
Can you ask again, because I missed one part of the sentence?
Is it possible in Spring Boot 2.0 use simultaneously Servlet API and WebFlux API?
Okay. So the answer is no, and the answer is yes. It depends how you see it. So one thing is Spring MVC, all the cases with the web client API I was showing, and the use of Reactor operators, all of that also works in Spring MVC. So you can benefit from the new web client API. You can compose data, use operators, and you can also return that in your controller with Spring MVC, and that will fall back to Servlet 3.1 async. So to some extent, there are some stuff that you can do with Spring MVC, and it will work, and there are others which won't work as easily. One of them is server-sent event. Server-sent event really means to stream data, and for that you need the reactive engine. As of running them at the same time, it's really a matter of you need to decide the main use case. So if your main use case is servlet-based app, then that's what you should do. And there are things that you can use with Flux and monos to a certain extent. And if that use case increases to a point, then you need to switch to a reactive-based web app. There's a question there. But
yeah, thanks for the talk. So the main question is, do we have a possibility to wrap the Spring Actuator with the Flux in the Spring way to make those endpoints reactive too, and support the event source streaming or something? Or
yeah,
website?
Thank you. That's a very good question. So. So the question is there a way to also make those reactive, so the actuator endpoints reactive? Actually, to some extent, that's already what we have. So the Earth indicator, for instance, when you invoke it, you have a bunch of Earth indicator. What we do is it's a bunch of Flux that we combine together. And the reactive streams implementation, so in this case, Reactor, will run them in parallel, potentially, depending on the resources. And there is timeout management and everything. So the Earth endpoint today is already reactive, so the one that I was showing. We have some, we would like also to, for instance, improve the log file endpoint, so that when you tail it, it will give you the entries in your log file in a reactive way. So these are the things that we would like to do. But the bottom line is, if you want them to be truly reactive, you need to change the implementation. You can't have a blocking implementation and just put something. It won't become reactive for that reason. So you don't understand you. Sorry. Can we have the mic there?
Yeah. But should we implement it customly, or Spring has some sort of solution for us out of the box?
Right. So if you have an endpoint that returns a publisher, we will detect that automatically. Yes.
Ah, okay. Thanks.
Okay. We are running out of time.
Run out of time. Sorry. My time is up. So feel free to come, and I'm happy to answer questions. Thank you. Have a good day.
Thanks a lot.